So far, you have stored single values and variables, but real programs need to store collections of data. Python gives you 4 core structures to do that: lists, tuples, dictionaries, and sets. In this episode, we go line by line through each one. A list is an ordered collection of items wrapped in square brackets and separated by commas. Lists are mutable, which means you can add, remove, or change items after the list is created. You access items using their index starting at 0. Negative indexes count from the end, so -1 gives you the last item. List can also hold items of different data types in the same collection. The append method adds a new item to the end of the list. The remove method finds the first occurrence of a value and removes it. The sort method rearranges the items in ascending order, alphabetically for strings and numerically for numbers. The len function returns the total number of items in the list. All of these operations modify the original list directly. List slicing works exactly like string slicing. You provide a start index, a colon, and an end index inside square brackets. The end index is not included in the result. Leaving the start empty starts from the beginning. Leaving the end empty goes to the last item. A step of -1 reverses the entire list, which is a very common trick in data processing. A tuple is like a list but immutable. Once you create it, you cannot add, remove, or change any of its items. Tuples use parentheses instead of square brackets. Accessing items works exactly the same way as a list using indexes. If you try to assign a new value to any item in a tuple, Python raises a type error immediately. Use tuples when your data must never be modified, such as GPS coordinates, color values, or fixed configuration settings. Tuple unpacking lets you assign each item in a tuple to its own variable in one line. Here we have a tuple with 2 values. Writing x, y equals coordinates assigns 10.5 to x and 20.43 to y. This is used constantly in Python. Functions that return multiple values return them as a tuple. You can unpack that result directly into separate variables as shown here. A dictionary stores data as key-value pairs inside curly braces. Each key is separated from its value by a colon, and pairs are separated by commas. Keys must be unique within a dictionary. To access a value, write the dictionary name followed by the key inside square brackets. If you try to access a key that does not exist this way, Python raises a key error. The safer approach is to use the get method, which returns a default value you specify instead of raising an error. Adding or updating a key uses the same syntax. Write the dictionary name, then the key in square brackets, then equals, then the value. If the key already exists, it gets updated. If it does not exist, it gets added. The del keyword removes a key and its value entirely. To loop through every key and value in a dictionary, use the items method, which returns each pair as a tuple that you can unpack directly in the for loop. A set stores only unique values. If you add a duplicate, Python silently ignores it. Here, we define a set with repeated values. When printed, each unique value appears only once. Sets use curly braces like dictionaries, but contain only values, no keys. Sets are unordered, meaning you cannot rely on a specific order when iterating. Use the add method to add items and the discard method to remove them. Checking whether an item exists in a set is extremely fast, which makes sets ideal for membership testing. Sets support mathematical operations directly. The pipe symbol gives you the union, which combines all items from both sets with no duplicates. The ampersand gives you the intersection, which returns only the items that appear in both sets. The minus sign gives you the difference, which returns items that are in the first set but not the second. These operations are commonly used in data processing when comparing collections. Here is a simple decision guide. Use a list when you need an ordered collection that you will modify over time and duplicates are acceptable. Use a tuple when the data is fixed and must not change. Use a dictionary when you need to look up values by a specific key. Use a set when you only care about unique values and need fast membership checks. Picking the right structure for the job makes your code faster and cleaner. You now know all 4 core data structures in Python: list for ordered mutable collections, tuples for fixed data, dictionaries for key value storage, and sets for unique items. In the next episode, we cover functions, where you will learn how to write reusable blocks of code. If you found this useful, Hit subscribe so you do not miss the rest of the series.